In this video we're going to look at the relationship between power and torque. And we will begin by assuming we have a mass m at a radius r from the center of a circle. So we're going to apply a force F to this mass, and if we apply a force to this mass, the mass will move along the circle to a point down here. And we're going to assume that the angle that makes is the angle theta, and the distance that the mass has traveled, we're going to call that distance s. Now, from definition of work is equal to force by distance. So we had a force and I moved this mass to this distance s. So our work, or the work done, was force by distance s. But from the definition of a radian, this distance s is equal to r times theta. And we also know that F by r, Fr, is torque. So force from the radius. So if I apply this force at radius r, that's a torque. So the work done is the torque times this angle theta measured in radians. Now power is defined as work over time, or the rate of doing work. So the power is W over T. So instead of W, I'm going to substitute in my torque times theta. So my power is torque times theta all over T, which is the same as torque times theta over T. Now theta is measured in radians and this is seconds. So radians per second. And radians per second is angular velocity. And we can change theta over T to omega, where omega is the angular velocity measured in radians per second. So the power is equal to torque times the radians per second. Now the angular velocity, omega, that can be derived from RPM. So the RPM n, so revs per minute, so divide by 60 to get revs per second, and there's 2 pi radians in a full revolution. So to convert revs per minute to radians per second, divide by 60 to bring it revs per second, and then multiply by 2 pi to get the number of radians per second. So the power is torque times the RPM by this factor here. Now if I look at this 2 pi over 60, 2 pi divided by 60 is equal to 0.1047, which is approximately equal to 0.1. And 0.1 is 1/10. So instead of having 2 pi over 60, what we could say is that the power is the torque times the revs per minute divided by 10, approximately. It just makes it easy to do in your head. So power is torque times revs per minute divided by 10.